Hi, welcome to my video on the new unit, which is circles. And in this unit, we're going to talk about the properties of chords, inscribed, central angles, tangents, sectors, secants. And this is the new unit. First video is on circles and chords, number 1. Complete each. These are some of the properties of dealing with a chord that's inside of a circle. A line perpendicular to a chord from the center of the circle. Line it bisects. So what we have is a circle, which we have a center, and a line perpendicular. So a chord is a segment drawn from the segment to two end points up to two ends of the segment are on the circle. So if we draw from the center, draw a line or a segment perpendicular to the chord. So we can say we can draw a line if we want to keep on going like that, or just this segment here. If it's perpendicular to the chord, then we'll bisect the chord. That means this point right here is the midpoint. And another property, which is the converse of this, a line segment drawn from the center of a circle to the midpoint of the chord is perpendicular to the chord. So what we mean here is very similar. We have a center of a circle. If a segment is drawn from the center, so let's say this is the chord, and let's say this is the midpoint M, and this is the center. We can say the center is O. I'm going to use O for the center all the time. So if a segment is drawn from the center of the circle to the midpoint, so there's the midpoint of this segment, that means that this segment will be perpendicular. So these two are converses of each other, reversed. And the third property we're dealing with on chords, equal chords are blank from the center of a circle. And equal chords are equal distance. Equal distance. Equal distance. So what we mean here is that two chords are equal distance from the center. So if equal chords, so this chord right here is equal in length to this chord, so if these two chords are the same length, then if this is the center of the circle, this distance here, which is the perpendicular distance, is equal to this distance here. So notice distance. When we say distance, we mean the perpendicular distance. So this distance is equal to this distance when these two chords, this one and this one, are equal. Chords equal distance from the center of the circle. So if chords are equal distance from the center, then the chords are equal. So that's the converse of this statement here. So what we mean is that we have a center of a circle. If chords are equal distance from the center, so if you take this chord and you take this chord, so if this equal distance from the center, so this distance right here, that's the perpendicular distance, is equal to this distance right here, which is the perpendicular. So if these two distances are equal, then these two chords are equal. And number 5, the perpendicular bisector of a chord passes through the center of the circle. So we have a circle and we have a chord, then, and that's the center. So the perpendicular bisector of the chord passes through the center. So if you take this segment and construct the perpendicular bisector, then the perpendicular bisector will go straight through the midpoint, which means this segment is equal to this one. This is perpendicular. So this is the perpendicular bisector because it's making this segment, cutting the segment two equal pieces, being perpendicular. Then this perpendicular bisector will travel through the center. And why? Well, if we take any point here, take any point on this perpendicular bisector, this distance is going to be equal to this one. This distance is going to be equal to this one. So any point on this perpendicular bisector is equal distance from these endpoints. You can do it by proving triangles congruent. That means it must pass through O, which is the center. Because if this distance equals this one, and this is the radius, then it passes the perpendicular bisector or goes to the center. And let's do some problems related to these properties. O is the center of the circle, and these circles came out to be a little bit faded, but again you can see them. So we have pH is equal to 24 centimeters, so pH is 24. Notice that OT is coming from the center perpendicular, so that makes this segment 12 and 12. And we want to find the exact parameter, exact circumference. Perimeter is circumference, but in a circle we call the distance around the circumference. So to get the circumference of a circle is 2 pi r, radius. So we need to get the radius. So we need to get the length of OP. So let's call OPX. Because we have a right triangle, that means C squared is A squared plus B squared. C is the hypotenuse, which is the X. A and B are 12 and 9. X squared is 144 plus 81. X squared is 225. So that means that X is plus or minus the square root of 225. So X is equal to plus or minus 15. But the radius is positive, so it's 15. So circumference is 2 pi times 15. And circumference is 30 pi centimeters. As the exact circumference. Exact means leave pi. Don't change pi. If you change pi to 3.14, then you're going to get an approximation. So to be exact, you need pi in your answer. Number 2, we have a circle. Again, this circle is a little bit faded. The printer didn't print it off perfect, but you can see the shape. Okay, here we go. Now, it says O is the center. It says that WV is 24, so this is 24 from here to here. ON is 5. ON is right here, centimeters. OJ is 11 centimeters. OJ is 11. We want to find the length of EF. So to get the length of EF, we know, let's see, we know this is 5, we know this is 24. Over here, we don't only know this is 11, but we don't know anything else. So if that's 24 and this is perpendicular here, a line from the center perpendicular to a chord bisects the chord, so that makes it 12 and 12. That means if we have a right triangle, so if I join up from O to W, I've created a right triangle. So let's call this X. So we work on the Pythagorean property. So what we have is that we got C squared equals A squared plus B squared. Again, X is equal to 5 squared plus 12 squared. X squared is 25 plus 144. X squared is 169. X is the plus or minus the square root of 169. X is plus or minus 13. And that means X is the radius, so the radius is 13. So if this is a 13, now we can join this one up. So OF, so OW equals OF, and OV, OE, they're all equal because they're radii. So if OW is 13, OF is 13. So we put a 13 here. Now we have another right triangle. So in this right triangle, right here, we can go, we get the hypotenuse. So let's use a Y for right here. So on this triangle right here, the hypotenuse is 13. So C squared is A squared plus B squared. So C is the hypotenuse of 13 squared. A is 11. B is Y. So 169, 11 squared is 121. So Y squared is 169 minus 121. Y squared is 48. So let's go over here. So Y is plus or minus the root of 48. And we have to simplify root of 48. Well, I see it's a 16 times 3. So Y is plus or minus 4 root 3. Square root of 16 is 4. And so Y is this PF. So that means this segment here is equal to it. So we can say that this one is 4 root 3 because this is perpendicular. This is 4 root 3. OJ is perpendicular to this segment from the center, so it bisects it, so two of them are equal. So that means that EF is equal to 4 root 3 plus 4 root 3, which is 8 root 3, as an exact value in simplest form, and that length is in centimeters. We can also say that EF is twice JF. So JF is the Y, so that's twice 4 root 3. When we multiply, we get 8 root 3. So we get the same answer. Either we can add the two of them together, or we can double. This segment is twice as long as either one of these parts. Okay, let's continue. We have a couple more to do using the properties. Number 3, O is the center of this circle right here. OT is 6. OT is 6, and that's 6 centimeters. And it says that TA is 8 and TB is 8. So it says because this is the segment drawn from the center to the chord, and this is bisecting AB, so that means that we have a right angle here because these two segments, TA and TB, are equal. But this segment coming from the center, that means we have a perpendicular. Because we have a perpendicular, we have a right triangle. But we don't have this piece. So let's join up this segment right here, O to B. So that means we have a triangle 6, 8, and let's put X on the hypotenuse. So C squared is A squared plus B squared. So X squared is 6 squared plus 8 squared. X squared is 36, 64. X squared is 100. X is plus or minus the square root of 100. X is plus or minus 10. And again, X is the radius, so the radius is 10 units, 10 centimeters. So if this is 10 centimeters, that means this is a radius from O to B. That means O to C is 10. That means we want to get the length of BC as a radical in simplest form. We want to get this length. So now we have triangle CTB. We have this segment is 16. This segment is 8. We can get BC. So C squared equals A squared plus B squared. And we have BC is, let's call this Y. So we got Y squared is equal to, this is 16. And B is 8. So Y squared, 16 squared is 256. 8 squared is 64. Their sum is, if you add them up, you'll get a 320. So Y equals plus or minus the square root of 320. And we break the 320 down. Now, a long way to break the 320 down would be to start dividing by 2. So 2, because it's even, into 320, that's a 160. Divide by 2 again is even, is an 80. Divide by 2 is a 40. Divide by 2 is a 20. Divide by 2, it's a 10. And 10 is a 2 times 5. So we have, notice that we have plus or minus. So we have, that's a 4, which is a 2. That's a 4, which is another 2. This is a 4, which is another 2 out, and the 5 can't come out. So y is plus or minus 8 root 5. So y is 8 root 5 as the exact value, and it's in centimeters. So I kept dividing by 2 and broke it down to break it up into, for every 2 factors that are the same underneath this root, we take 1 out. So we could have said that was 64 times 5 from the beginning. But we didn't, I just wanted to show you dividing by 2 here. Number 4, O is the center of this circle. AB is 4 root 15, so AB, this distance here, from here to here, is 4 root 15. OH is root 5, so that's root 5 right there. And again, we want to find the length of TV, which is this segment, as a radical in its simplest form. But I made up the diagram to be a little bit different with some extra work in there. So we have, this is the center, perpendicular to the chord. That means it bisects the chord. So that means that's 4 root 15. So this is 2 root 15 and 2 root 15. So now we have this triangle, which is c squared is a squared plus b squared. In this triangle, c is the hypotenuse opposite the right angle, so it's a 2x squared. A is just x being squared, and b is 2 root 15 being squared. 2x squared, 2x times 2x is 4x squared, x squared. So 2 root 15 times 2 root 15, 2 times 2 is 4. Root 15 times root 15 is 15, so that gives me a 60. So we have 4x squared minus x squared equals 60. 3x squared equals 60. Divide by 3, x squared equals 20. X equals plus or minus square root of 20. And the square root of 20 is 4 times 5. So x is equal to plus or minus, square root of 4 is 2, root 5. And the radius is 2x. So that means it's 2 times 2 root 5. So the radius is 4 root 5. So this is 4 root 5 going down right here. Now, if I, it's 4 root 5, if I join this up, this radius OB is equal to OB. So this is 4 root 5. So we have a right triangle perpendicular here. So in this triangle, we have, this is the C, that's the A, and that's the B. So in that triangle, we have C squared is A squared plus B squared. I have an X here, so let's put a Y or any value here. I could say HV, but it's easier to put a Y in. So C is 4 root 5 being squared. A is root 5 being squared, and a Y squared. So 4 root 5 times 4 root 5 is 16 times 5. 16 times 5 makes 80. Root 5 squared is 5. That means that y squared is 80 minus 5. Y squared is 75. Y is plus or minus the root of 75. Root of 75 is 25 times 3. So that's plus or minus, make 5 root 3. So that means that we have y is positive, so it's just a 5 root 3. And again, TV is twice HV, so that's twice 5 root 3. So TV is 10 root 3, and is in centimeters. Again, very similar to the other one we did, but I just wanted to do some more math with quadratics here and do more radicals. Just review the radicals. So that's reviewing some of them properties and use the math that you learned on Pythagoras and radicals, etc., etc. And if you like my video, click on the like button. Click on the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that I have on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.